Let's discuss about arithmetic sequence. When we use arithmetic sequence, we are going to use this formula. We have a sub n is equal to a sub 1 plus the quantity n minus 1 times d. And here, our a sub 1, that is the first term in a given arithmetic sequence. Always the prime term is our a sub 1. Then our n here, that represents the position of the number that will be identified. Then our d, that is our constant difference. And our a sub n, that is the unknown term in a given arithmetic sequence. Now, the first step to find out the unknown term of this arithmetic sequence is to determine first our constant difference. And the formula for finding out the value of our constant difference is we have this. D is equal to a sub 2 minus a sub 1. Wherein our a sub 2 is our second term and our a sub 1 is our first term. So let's have this example. Let's say we are going to find the 237th term of the arithmetic sequence whose elements are as follows. Let's say we have the first term, we have 12,589. Let's say 12,589 x to the power of 5. Then we have the following. We have 13,939 x to the power of 5. Then followed by, we have 15,289 x raised to the power of 5, and so on and so forth. I have here our sign of infinity, which means to say that it would be the succession of the following terms or the following elements. It is unending. Now, the first step is we are going to find out our constant difference. By using our formula, we have d is equal to a sub 2 minus a sub 1. We are just going to plug in the values of our a sub 2 and a sub 1. Here, this is our a sub 1 and this is that's our a sub 2. We are just going to substitute these values with our corresponding variables of our formula for constant difference. D is equal to, we have 13,939 x to the power of 5 minus 12,589 x to the power of 5. We will just subtract this. Then we will be able to find out the value of our constant ratio. And now, our constant difference now, we have 1,350 x to the power of 5. This is our constant difference. And if we are able to find out the value of our d, we are now ready to find out our 237th term of the given arithmetic sequence. The next is we are going to apply the formula. The formula to find out the unknown term. We have here a sub n is equal to a sub 1 plus the quantity n minus 1 times d. And our n here is 237 because that is the position of the element that will be identified. We have now a sub 237 is equal to our a sub 1. We have 12,589 x raised to the power of 5 plus our n is using the subscript of our a sub n. And that's equal to 237 deducted by 1, then multiplied by our constant difference, which is 1,350 x raised to the power of 5. Next is we are going to simplify. Just copy your 12,589 x raised to the power of 5 plus you subtract 237 and 1. We will have 236 multiplied by 1,350 x raised to the power of 5. Then copy 12,589 x raised to the power of 5 plus you multiply 236 by 1,350 x raised to the power of 5, and we will be able to obtain 318,600 x raised to the power of 5. Then we will combine this. This will be now the value of our 237th term. And the result now, we have a sub 237 is equal to 331,189 x raised to the power of 5. And this is now the value of the term, which is 237 from the given arithmetic sequence. Now, let's talk about arithmetic series. Arithmetic series is different from arithmetic sequence. Series talks about the total of the elements that are in a particular arrangement. When we say arithmetic series, this is the sum of all terms in a given arithmetic sequence. We are going to find out the total of the prescribed terms. Our formula here, we have this formula. We have S sub n is equal to n over 2 multiplied by 2a sub 1 plus the quantity n minus 1 times d. Eventually here, we are going to find out again the value of our constant difference together with identifying our first term. So let's have an example here. Find the sum of the first 100 natural numbers. So this is the problem. We are going to find out the sum of the first 100 natural numbers. When we say natural numbers, this talks about the set of counting numbers. Okay? The numbers that are used for counting. And our a sub 1 here is definitely 1, because when we start counting, we usually begin at 1, not 2, not even 0. We are going to start counting using 1. Remember that natural numbers are also known as counting numbers. The set of natural numbers is also the set of counting numbers. Take note of that. Then, we are going to find out what is our constant difference. And by analyzing the set of the first 100 natural numbers, by applying the formula, we have to subtract the second term of the first 100 natural numbers, and we have a sub 1. The second term from the set of the first 100 natural numbers, we have 2. Then of course our first term is 1, and let us subtract this. We will be getting the value of 1. This is our constant difference. By applying our formula, we can now plug in the values of our a sub 1, our first term, together with our constant difference using the formula that I just set here. So now we have s sub n is equal to n over 2, then multiplied by 2a sub 1 plus the difference between n and 1 multiplied by d. Since we are looking for the sum of the first 100 terms, our n now will become 100. Okay, then our 100 here, the subscript of our s will be used here in our numerator, 100 all over 2. Then multiplied by 2 twice our a sub 1. Our a sub 1 is 1 plus our n is still 100 minus 1 multiplied by our constant difference, which is also equal to 1. Next, we simplify. 100 divided by 2 here, we have 50. Then the product of 2 and 1 is 2 plus, you're going to subtract 101, we will have 99 multiplied by 1. Then, we have to continue simplifying. 50, then 2 plus the product of 99 and 1, that's 99. After this, we are going to combine 2 and 99 and multiply it using 50. We have now 50 multiplied by the sum of 2 and 99, which is equal to 101. Then the sum of the first 100 arithmetic sequence now, we multiply 50 and 101. That will give us 5,050. So if you are going to add, starting from 1, 2, 3, 4, 5, until you reach your 100, the total of those terms will be equal to 5,050. That is the set of the first 100 counting numbers. If you're going to find out the total of those involved set. Okay? And this is arithmetic series. Now, let's go to geometric sequence. Geometric sequence is denoted by this formula. And our formula here is, we have a sub n is equal to a sub 1 r raised to n minus 1. That's our formula. When we say a sub n, again, that is the nth term, or that is known to be the unknown term. That is the value that will be identified or determined based from the given problem. Then our a sub n, that will be our first term or the first element in the given sequence. And our r will be our constant ratio. Again, the first step, if you are going to identify the unknown term of a given geometric sequence, you're going to find out the value of our constant ratio. Our constant ratio is denoted by this formula. R is equal to our second term divided by our first term. Okay, so let's have this example. Find the seventh term of the geometric sequence of find the seventh term of the geometric sequence whose terms are the following. So let's say we have here 5,884 x raised to the power of 4, then followed by 17,652 x raised to the power of 4 and followed by 5,000, let's say 52,956 rather, and so on and so forth. So we're going to find out the seventh term. What would be the value of our seventh term from our given problem? Again, our first step is we're going to find out the value of our constant ratio, denoted by R. R is equal to the second term divided by the first term. We have now 17,652 x raised to the power of 4 all over 5,884 x raised to the power of 4. So if we'll be dividing this 17,652 divided by 5,884, we will have our R, which is equal to 3. Okay, and our x to the power of 4 will be cancelled out. So our constant ratio is equivalent to 4. Now we are ready to find out our seventh term. Since our first term, we have our a sub 1, we have its value, it is equal to 5,884 x raised to the power of 4. By using our formula, we have a sub n is equal to a sub 1 r raised to n minus 1. And we are asked to find out the seventh term. So we have a sub 7 is equal to our a sub 1 is 5,884 x raised to the power of 4 multiplied by our constant ratio 3 raised to, our n here is 7, so 7 minus 1. Then continue simplifying. Let us copy 5,884 x to the power of 4. Then 3 raised to the power of 6. And we will have now our seventh term. We have 5,884 x raised to the power of 4. Then 3 raised to the 6th power. This will give us 729. And multiplying our two numbers here, 5,884 multiplied by 729 and suffix your x to the power of 4, this will give us the value of our seventh term, which is 4,289,436 x raised to the power of 4. This is our seventh term from the given problem. Next, let's talk about geometric series. Our geometric series is different from geometric sequence. As what I mentioned a while ago, series is talking about the summation, the total, or the sum. So when we say geometric series, this is the total of the terms in a given geometric sequence. And we have the formula for finite geometric series. We have S sub n is equal to, we have a sub 1 multiplied by r raised to n minus 1 all over r minus 1. This is the formula for determining the value of, let's say, the series of a particular geometric sequence. This is a finite geometric series formula. Let's have the problem. Find the sum of the first 8 terms of the geometric sequence with the following terms or the following elements. Let's say we have we have 6,325. 6,325 AB and followed by 12,650 AB, and we have 25,300 AB, and so on and so forth. Again, the first procedure that must be done is finding out the value of our constant ratio. We have R is equal to, again, following the formula, we have A sub 2 divided by A sub 1. And our first term here, we have 6,325 AB. And our second term here is 12,650 AB. So we will divide these two expressions. We have now R is equal to 12,650 AB divided by 6,325 AB. This will be cancelled out, and if you divide 12,650 by 6,325, this will give us the value of our constant ratio, which is equal to 2. Okay, since our A sub 1 here is also given, we have 6,325 AB, we are now ready to plug in these values using our finite geometric series formula. Okay, we have now S sub n is equal to A sub 1 multiplied by R raised to n minus 1 all over R minus 1. Since we are going to find out the sum of the first 8 terms of the given geometric sequence, we are going to use now S sub 8 is equal to our A sub 1. We have 6,325 AB. Then multiplied by our constant ratio, which is equal to 2 raised to n. Our n here is 8. So 2 raised to 8 minus 1 all over 2 minus 1. Then we have also to remember that in using our finite geometric series, our constant ratio should not be equal to 1. Because if our constant ratio is equivalent to 1, then the value will be indeterminate. You have to remember that. Our constant ratio should always be above 1. It should not be equal to 1. Because if our constant ratio is equivalent to 1, then that will become undefined. Okay? So let us proceed. Let us simplify now. We have the sum of the first 8 terms of the given geometric sequence now. You copy your numerator, 6,325. Then you simplify 2 raised to the power of 8. This will give us 256 minus 1. Then 2 minus 1. In our denominator, we have 1. And then we have now 6,325 AB. You subtract 256 and 1. We have 255. Then, dividing this by 1. we have now S sub 8 is equal to, we are going to multiply 6,325 multiplied by 255. We have now the value, we have 1,612,875 AB all over 1. And remember, we have your 1 as your denominator. Therefore, the answer will be the numerator itself. Because any number, when divided by 1, the number being divided will be the answer. We have now the sum of the first 8 terms of the given geometric sequence. We have 1,612,875 AB. This means to say that if you are going to add your first term, your second term, third term, and finding out your fourth term, fifth, sixth, seven, and eight, if you will be getting the total of those 8 terms, then you will arrive getting this value. Okay. Now, let's go to harmonic sequence. Harmonic sequence is the reciprocal of arithmetic sequence. If we are going to use the formula for arithmetic sequence, we will just put 1 as the numerator, then the denominator of that will be the arithmetic sequence formula, and that will give us our harmonic sequence formula. We have here a sub n is equal to 1 all over a sub 1 plus the quantity n minus 1 times d. If you could remember, the denominator itself is the formula for arithmetic sequence. And if you are going to find out the reciprocal of an arithmetic sequence, that will give us harmonic sequence. Now let us try to find out the unknown. Let's say this problem. Determine the 456th term of the harmonic sequence if the following are its terms. So let's say we have 1 all over 1 all over 68,589. Let's say x squared. Then we have 1 all over 79,469 x squared. And we have 1 all over 90,349 x squared, and so on and so forth. Here, class, if we are going to look for the value of the unknown term of this given harmonic sequence, we are just going to consider the denominators of the given terms in this set of harmonic sequence. Only the denominators will be used. Because remember, it is known to be harmonic if the numerators are all equivalent to 1. So, let us find out our constant difference first. We have d is equal to a sub 2 minus a sub 1. Remember, when we replace our a sub 2, we are just going to consider the denominators, not the complete term of the given harmonic sequence, just the denominator of the terms that are involved. Our a sub 2 here, using its denominator, we have 79,469 x squared is deducted by the denominator of the first term, which is 68,589 x squared. And if we are going to subtract this 79,469 x squared minus 68,589, this will give us the difference of 10,880 x squared. So this is now the value of our constant difference. Now our a sub 1, we will use just the denominator of the first term, okay? Our a sub 1 is 68,589 x squared. Then by following our formula, we're just going to plug in these values to our harmonic sequence formula. We have a sub n is equal to 1 all over a sub 1 plus n minus 1 multiplied by d. Since we are asked to find out the 456th term, that will serve as our n. We have now a sub 456 is equal to 1 all over our a sub 1. We have 68,589 x squared plus our n is 456 minus 1 times our d, which is equal to 10,880 x squared. Now let us continue simplifying this. Our 456 term is equal to 1 all over. You copy 68,589 x squared plus you subtract 456 by 1, we have 455. Then you multiply it using 10,880 x squared. After this, we have our 456 term is equal to 1 all over 68,589 x squared. Then you multiply 455 multiplied by 10,880 x squared. This will give us 4,950,400 x squared. Then we are almost there. We have now a sub 456 is equal to 1 all over. You add your denominators. We have here 68,589 x squared plus 4,950,400 x squared. This will give us 1 all over 5,018,989 x squared. And this is our 456 term from the given harmonic sequence. That's all. Thank you.